Hello, I'm Naomi and I'm Public Engagement Manager for the Mathematics of Waves and Materials Research Group at the University of Manchester. Researchers in our group use applied mathematics alongside ideas from physics, materials science, chemistry and engineering to model and test the properties of materials and waves. These might include elastic, acoustic, electromagnetic or water waves. So waves and materials affect our lives in lots of different ways. Every time we use an object or hear a noise, there are interactions governed by acoustic and material properties that can be understood using maths.
Researchers in the group use maths to understand what happens when a light or sound wave meets a material's surface. It could be transmitted or absorbed, reflected as we see here. It could be diffracted, bent around the object, or refracted, like we see here.
And there are many applications of this. They include things like predicting how sound is going to be transmitted, or the way ice crystals within clouds diffract sunlight, and that's of interest for climate change modelling. This time of year we're surrounded by lights of all types, so I thought I'd show you something that we can make that uses fairy lights and also this idea of transmission and reflection of light. And it's this clever little box here. So it's only a few centimetres deep, and it's got LED lights all the way around and a picture frame on the top. And then you can see, hopefully you can see a reflection. There's a quilt there reflected in it. So it's behaving like a mirror at the moment. But if I turn the LED lights on, we see something quite extraordinary. So it looks as though it goes on and on and on forever. You get this illusion, an optical illusion of depth. And if I turn the lights off in the room, you should be able to see that even better. So hold on for a minute. And hopefully you can see that really cool effect. And this is called an infinity mirror for obvious reasons. So this one's unfinished. You can see it looks a bit scruffy. That's so that I can take the lid off and show you how it's made. So it's just a shallow box and there are fairy lights running all the way through the inside. And on the bottom we've got a ordinary mirror, but the clever bit is in the lid, and it's just a piece of glass. I've just used a picture frame, and on the glass is a special film, and it's called one-way mirror film. And a mirror works by having a sheet of glass or plastic, and on the back is a highly reflective coating, so it's usually a thin layer of aluminium or silver, so a metallic coating, and it's called silvering, covering the back of the glass like that. But the mirror film, the one-way mirror film, is called half silvered, so it's only partially coated with a metallic coating, so that allows some of the light to be transmitted and then some of the light to be reflected. So what we see through a one-way mirror depends on the amount of light on either side of it. So if I'm going to put the lid back on, and so if the LEDs are switched off, there's much more light outside the box than inside the box. So we see much more light being reflected back to us than being transmitted from inside the box where it's very dark. As soon as I turn the light on, now there's much more light inside the box. So what we're seeing is what's being transmitted through the film, and it's much more than what we'd see reflected from the outside.
Aside from the box and a mirror to fit the base, you'll need a piece of glass or perspex that fits the top. I used a picture frame. And you'll need some of this film to cover it, and this is called window privacy film
or one-way mirror film, and you can buy it online or in large DIY stores. You need a cheap string of LED lights, and I've also got double-sided tape and some duct tape just to go around the sides of the box.
Download the information sheet for instructions and safety guidance.
Here's the box again, and I've made holes all the way around the outside edge, and I've glued the mirror into the base of the box. I've just got it covered up with this cloth because otherwise you can see the reflection of my phone and microphone, which is quite distracting, and this will also keep my fingerprints off the mirror while I'm working. And I'm going to take my string of fairy lights and I'm just going to thread every LED through the holes and just leave the wire on the outside for now. I'm going to cover that up with tape later. I'm going to keep going round, and so just count your LEDs before you make the holes and then you'll know how many holes you need. And I've got enough to go around twice with my LEDs, so there's actually going to be 2 LEDs poking out of each hole when I've finished. So here is my piece of glass, and if you're using glass, do be careful. Again, you can use clear plastic like Perspex as an alternative. And I've cut a piece of the window film, and it's a couple of centimetres bigger than the piece of glass all the way round. Now, the way to apply the film depends on the manufacturer. Mine's adhesive, it's got a backing that you peel off, but you have to wet the glass to apply it. So I'm going to go ahead and take this into my kitchen and put the film on there. There's a few air bubbles, but that doesn't really matter. And I've just taped up the sharp edges there. And I've made a hole in the box lid that's big enough to accommodate the glass, and there's some tape all around the edges. So I'm going to stick the piece of glass in and just press down firmly. So that's our lid. All that remains to do is put the lid on the box and switch out the light and turn it on. And there you have it. There is our infinity mirror with reflections going on forever. And what's happening is the light from the LEDs is reaching our one-way mirror film, and part of it is being transmitted so that we can see it, and then part of it is being reflected from that half-silvered surface. It hits the mirror at the bottom and is reflected back again, and the whole thing repeats, so some of the light reaches our eyes and some is reflected back again to the mirror, and over again. So we get a sequence of reflections, and each one is a little bit dimmer, is a little bit less light is being reflected each time, and we get this impression, this optical illusion of depth. I hope you've enjoyed this demo. Don't forget to check out the MWM Maths YouTube channel, where you can see videos of our PhD students talking about their research in the Waves and Materials group, and you can also find lots of experiments to try at home.